my healthcare brothers and sisters. I hope that you all are having a wonderful day. Today we're going to tackle a little bit of a tricky topic when it comes to the ATI TEAS math portion of the exam, and that is algebraic equations. In this video, I'd like to go ahead and extend an invitation for you to go ahead and subscribe to me down below. If you haven't already subscribed, where have you been, all my ATI TEAS people? Make sure that you hit that big thumbs up to let other people know that are looking for the ATI TEAS reviews that I'm doing a good job and that this information is helpful for you for passing your ATI TEAS like a boss. Let's get started. So to begin with algebraic equations on the ATI TEAS, we're going to start by simplifying equations. Now, one of the easiest ways to simplify an algebraic equation is to combine like terms. Like terms are described as terms that contain the same variables or no variables at all, raised by the same power. So let's go ahead and take a look at this example that I have below. X squared plus 4x plus 1 plus 2x squared plus x plus 8. Now there's a lot of numbers in there and there's a lot of x's in there, so let's break this down. In order to simplify this expression, we must combine these like terms. So for example, x squared and 2x squared are like terms. They're both x squared. They both contain the same power and they both contain the same variable raised by the second power. In addition, 4x and x are also considered like terms because neither one of them has an exponent. They don't have a square behind them. So 4x plus x are also like terms. Lastly, 1 and 8 are like terms because neither one of them contains the variable x or any other variable at all. So we can start by combining these terms. X squared plus 2x squared plus 4x plus x plus 1 plus 8. Now that we've got all of our variables and our exponents in a fashionable order, we're going to go ahead and start simplifying. So x squared plus 2x is 3x squared. 4x plus x is 5x, and 1 plus 8 is equal to 9. So our answer to the algebraic equation is 3x squared plus 5x plus 9. Simplifying algebraic equations really isn't that difficult once you start to see the like terms within the equation. However, what do we have to do when we start multiplying these variables and exponents? Well, let's take a look. We're going to use something called the FOIL method. So the FOIL method expression is requiring the applicant to multiply two binomials. So binomials are defined as equations that contain the same like terms. FOIL is primarily used with multiplication of these binomials, and we're going to go ahead and take a look at an example. So our example is parentheses x plus 2 multiplied by parentheses 2x plus 4. FOIL stands for first, outer, inner, and last. So this is the order in which we are going to multiply these binomials. So for example, x plus 2 parentheses 2x plus 4 parentheses. So first we multiply the two terms at the beginning of each binomial. So in the first binomial we have x, and in the second binomial we have 2x. So we're going to multiply x by 2x, which leaves us with 2x squared. So step 2 is we're going to multiply the outer terms of each binomial. What numbers are on the outer parts of the binomials? So we've got x and 4. So we're going to multiply x by 4 and we get 4x. Step 3, we're going to multiply the inner terms. What's on the inner side of the binomials? So we've got 2 times 2x. 2 is on the inside, 2x is on the inside. We're going to multiply those together. 2 by 2x, we're going to get 4x. And our last and final step in the FOIL method of multiplying algebraic equations is we're going to multiply the two terms that are last in each binomial. So we've got 2 and 4. Those are the last numbers in each of our binomials. We're going to multiply 2 by 4 and we're going to get 8. We're going to take all that data that we collected by multiplying this algebraic equation and we're going to start putting things together. So we've got 2x squared plus 4x plus 4x plus 8. Well, we know that 4x and 4x are like terms so that we can add those together. So that gives us our final answer for this equation is 2x squared plus 8x plus 8, and that is the answer to our algebraic question example. Adding and multiplying algebraic equations really aren't that difficult, but once we start looking to solve those variation equations within the algebraic equations, that's when it becomes a little bit more difficult. So stay with me here, we're going to get through this. Algebraic equations can be confusing once they involve one unknown variable. This variable is usually represented by the letter x or y. These equation tests test the applicant's ability to find the unknown variable. So let's take a look at our first example. We have 3x plus 6 equals 9. The example wants you to find the value of x. In order to solve this equation, we must first begin by isolating the variable on one side of the equation. How do we do that? We begin by subtracting 6 from both sides of the equal sign. It's important to note that what is done on one side of the equal sign has to also be done on the other side of the equal sign. So we have 3x plus 6 equals 9. In order to get rid of that 6 on the left side of the equal sign, we have to subtract it by 6. And that way, when we do plus 6 minus 6, we get 0, and that equals each other out. But like I said before, what we do on one side also has to be done on the other side. So we are going to subtract 6 on the right side of the equation sign as well. So that is going to leave us with 3x plus 6 minus 6 equals 9 minus 6. Well, like I said before, plus 6 minus 6 equals 0, and 9 minus 6 equals 3. So that leaves us with 3x equals 3. However, we still have a number before that variable, so we have to get rid of that number as well. How do we do that? We are going to divide 3 on one side of the equation by 3 on the other side of the equal sign. So once we are able to isolate that, we have 3x over 3. That cancels out our 3's, leaving us with just x. And on the right side of our equal sign, we have 3 divided by 3, which is equal to 1. So we know the final answer for this question is x is equal to 1. It's a lot of work, but once you get the hang of it, it becomes super simple and super easy on the ATI TEAS. Moving on, we're going to start learning how to solve inequality equations. Now, inequality equations express the relationship between two quantities where one quantity may be greater, less than, or equal to another quantity. So what are examples of inequality symbols? Well, as you can see from the PowerPoint here, we have the greater than, the less than symbol, the greater than or equal to symbol, and the less than or equal to symbol. So let's take a look at an equation and see if we can't figure this out. We have negative 3x is greater than 9. Now, inequality equations are solved the same way as equations with the exception of one thing. When multiplying or dividing both sides of an inequality by a negative number, you must reverse the direction of the inequality sign. Now, I know that gets a little confusing, so let's take a look at this so that way we can figure this out together. Now, we've got our example. Negative 3x is greater than 9. In order to solve this equation, we must isolate the variable x on one side of the equation. Just like we did before, we are going to do the same thing as we do on one side of the inequality as we do on the other side of the inequality. So we are going to isolate x. How we're going to do that? We're going to divide it by negative 3. Negative 3 and negative 3 equal each other out, and we are left with x is greater than 9 over negative 3. However, we're dividing by a negative. So what does that mean? We have to switch our inequality sign. So it's going to go from greater than to less than. We're literally just taking it from one direction and moving it into the other direction. So we've got x is less than 9 over negative 3. Notice that sign change is very, very important. That leaves us with our final equation answer, which is x is less than negative 3. Absolute value equations. The absolute value of a number is the distance the number lies from 0 on a number line. Absolute value equations are indicated by two vertical bars. So you might see the two vertical bars with an x inside is equal to 6. That is an example of an absolute value equation. Let's figure out how to solve this. If the absolute value of x is equal to 6, then x must lie equally 6 units away from 0 on the number line. This means that x can either be positive 6 or it can be a negative 6. So the answer is both 6 and negative 6 because they both lie exactly 6 units away from 0. Well, let's take a look at another equation. Absolute value x minus 3 is equal to 6. This equation is slightly different and a little bit more difficult. We understand that the absolute value of x minus 3 is 6. This informs us that the quantity x minus 3 lies equally 6 units away from 0, meaning that x minus 3 could equally be 6 or negative 6. We'll set up the equation for both to solve for the answer. So as you can see here from the PowerPoint, we have the absolute value of x minus 3 is equal to 6, and the absolute value of x minus 3 is equal to negative 6. So we're going to go ahead and solve for both. How do we do that? Now that we have figured out the absolute values of x minus 3 is equal to 6, then we can go ahead and just get rid of those bars next to the x minus 3 and just perform the equation as we regularly would. The first equation, x minus 3 is equal to 6, we are going to add 3 on both sides of the equation. As we said before, what you do on one side of the equation symbol, you're going to do on the other side of the equation symbol. So we're going to add 3 on the left, we're going to add 3 on the right. That crosses out our 3's on the left, and that leaves us with 9 on the right. So we know that x is equal to 9, but we're not done yet. We have to figure out the absolute value. So we have a second equation. Our second equation is x minus 3 is equal to negative 6. We're going to go ahead and perform the same thing that we did before. We're going to add 3 on the left-hand side, and we're going to add 3 on the right-hand side. Our 3's are going to cancel each other out on the left-hand side, and negative 6 plus 3 on the right-hand side is equal to negative 3. So x is equal to negative 3. So we know that the absolute value of x minus 3 is equal to 6. X is both 9, and x is also negative 3. If you haven't done so already, I want you to head over to my website at www.nursecheung.com. There I've got additional resources for you for your ATI TEAS exam. That includes additional practice questions for you to take on your own if you're having some difficulty with these topics. I've also included the PowerPoints if you want to print those out and take notes as we're going along, and as well as the PDF of the Word document where, everybody learns a little bit differently. Some people learn better with PowerPoint notes and some people learn better with just the Word document itself. So go ahead and go over there and check that out so that way we can pass this ATI TEAS the first time and kill it like a boss. So I hope that this information was helpful for you to pass your ATI TEAS math portion of the exam. I'm going to start doing some Facebook Live videos of review questions and different topics on the ATI TEAS that may help you get a better understanding and get some additional practice in before you step in there and hopefully reduce that anxiety so that you don't have to worry about this. You know you're going to pass this like a boss. So go ahead and go on over there. Make sure that you like that page. That's facebook.com/nursecheung, where I'll be posting when I'll be doing those videos. That's hopefully at a convenient time for you. If not, they'll go ahead and be posted down here so that you can kind of play along with me as we did over on Facebook, just kind of on your own practice. But if you're not already following any of my social media, go ahead and check me out. I'm at Nurse Cheung on Facebook, Instagram, and Twitter. But until next time, I hope that y'all are having a wonderful day, and I look forward to speaking with you all again soon. Bye!